Alright, chemistry, this is another sample problem coming at you from chapter 7, section 3. In this sample problem, we're going to be calculating percent composition of silver sulfate. Again, we are going to need to calculate the molar mass of the substance. Again, it doesn't matter how much of the substance we have because we are calculating a percentage. And so regardless of the sample size of the substance, the percentages should always be the same. And so we're going to assume there's 1 mole of the substance. And you might ask, why do we choose 1 mole? Because it's very, very simple and easy to work with. We could just as easily pick 100 moles, we could pick 1,000,000 moles, we could pick 32 moles. But 1 mole is a lot easier to work with. So let's start by calculating the molar mass of silver sulfate. Start by listing all of the elements that are present in this substance. I will then move to the periodic table and figure out the average molar mass of each element present. Silver is going to come in at 107.87 grams per mole. Sulfur is going to come in at 32.06 grams per mole, and oxygen is going to come in at 16.00 grams per mole. Next, I'm going to identify or take into account how many moles of each individual element are present in 1 mole of this entire compound. So for every 1 mole of this entire compound, I have 2 moles of silver, I have 1 mole of sulfur, and then 4 moles of oxygen. Next, I'll actually calculate this out. I'll actually do this multiplication. 107.87 times 2 is out to be 215.74 grams. This one's easy. I can do this in my head. 32.06 grams. And then 16.00 times 4, 64.00 grams. So I am going to sum these all together, but I do want to point out if you use this procedure here and calculate the mass due to each individual element first, you can actually go back and use these masses later on to make it easier for you. So I do suggest using this exact same procedure in the future. Alright, so I am going to put all of these values into my calculator so I can get the sum. The calculator tells me that the sum is 311.8. Here's the thing. I have to take into consideration how many significant figures I should have. Now, we are using addition here. That's the function that we're carrying out. And the significant figure rule for addition is that we have to have the same number of digits past the decimal point as is present in the value with the fewest number of digits past the decimal point that we're adding. All of these values have 2 digits past the decimal place. But notice, the calculator said 0.8, only 1 digit past the decimal place. Well, that's because there is a 0 there. So we'll add a 0, and we will now have 2 digits past the decimal place. We will have the appropriate number of significant figures recorded. And so the molar mass of silver sulfate is 311.80 grams per mole. Now, because I'm doing percent composition, I'm going to take the mass due to silver, divide it by the mass of the entire substance, turn that into a percentage. Take the mass due to sulfur, divide that by the mass of the whole compound, turn that into a percentage, and then take the mass due to oxygen and divide it by the mass of the substance and then turn that into a percentage. So what that's going to look like, we'll have 215.74 divided by 311.80. I'll come out with a value there, turn it into a percentage, and that will be my percent silver. Alright, next I'll take 32.06, divide that by 311.80. I'm going to turn that into a percentage, and that will be my percent due to sulfur. And then lastly, I'll take 64.00 divided by 311.80, take whatever decimal that is, multiply it by 100, and that will be my percent due to oxygen. Now, if I were to add all of these percentages up, they should come out to be very, very close to 100%. Oftentimes, it will be exactly 100%. It doesn't have to be. It can be off by a couple hundredths of a percentage, but if you're off by a whole percentage, then probably there's something off there. So let's see if we are on point. Let's actually carry out these divisions. 215.74 divided by 311.8. That decimal, again, I'm already reading that I should have 5 significant figures there. 0.69192. Just cut to the chase there. That becomes 69.192% silver. 32.0 for moving on to sulfur. 32.06 divided by 311.80. That comes out to be a decimal 0.1028. Again, there's 4 significant figures here, so this needs to have 4 significant figures. Turn that into a percentage. We'll have 10.28% sulfur. And I will end with oxygen, 64.00 divided by 311.80. And the decimal, I see it should also have 4 significant figures, 0.2053. And that turns out to be 20.53% oxygen. Now, when you put these into the calculator, which we can do real fast for you, or can we? This comes out to be 100.002, so we're actually off by 0.02 of a percentage point. And that's okay. That's well within the realm of percentage error, because again, we are working with a limited number of significant figures based on our periodic table and your periodic table that you're using at home. We don't have access to an infinite amount of precision, and so these values will very often, often not equal 100 exactly. We're actually off by 0.002, but that is perfectly okay for the scope of this course. So the percent composition of silver sulfate is going to be 69.192% silver, 10.28% sulfur, and then 20.53% oxygen.